Hello everyone, I'm Hongsuk Choi, the presenter of Learning to Estimate Robust 3D Human Mesh from In the Wild Crowded Scenes. While there has been a lot of progress on 3D human mesh estimation, SOTA methods still struggle on the in the wild images with a crowd. The more interpersonal occlusion, the more they struggle. One of the main reasons for this failure is the large domain gap between mocap training data and in the wild crowd testing data. The other reason is the global average pulling on a deep CNN feature of a crowd image. Spatially averaging the deep CNN feature may blow away the target person's activation. Our core idea is first to leverage an external 2D pulse estimator to explicitly guide the deep CNN to extract a crowded scene robust image feature. Second is to use joint-based regressor that does not blow away the spatial activation of a target person in a feature map with the global average pulling. We curated a new evaluation benchmark named 3DPW Crowd. The principal obstacle of pose estimation from crowded scenes is not the number of people but interpersonal occlusion. Existing 3D benchmarks has few interpersonal occlusion, while 3DPW Crowd has a lot. The diagram shows that 3DPW Crowd has much higher bounding box IOU and crowd index than traditional 3D benchmarks. Our method is named as a 3DCrowdNet. Note that 3DCrowdNet estimates a single person's mesh from an image. The large domain gap issue is resolved in the feature extracting stage. The global average pulling is replaced with joint-based feature sampling. So, is the 2D pulse estimator helpful? Yes. Given the 2D pulse guidance, the area of a target person is much more activated correctly. On 3DPW crowd, MPJP is lowered by 23.8 millimeters, and PA MPJP is lowered by 7.5 millimeters. Using a joint-based regressor instead of global average pulling is also beneficial on increasing accuracy of estimation on crowded scenes. On 3D Crowd, ours decrease MPJP by 3.2 millimeters and PMPJP by 3.7 millimeters compared with spin style regressor that does the global average pulling. Also, the sampling area matters. Too large sampling area can include other person's features and deteriorates the accuracy. 3DCrowdNet achieves state-of-the-art accuracy on 3D crowd with a large margin. We also provide experiments on other 3D benchmarks. Qualitative comparison between 3DCrowdNet and SPIN. Qualitative comparison between 3DCrowdNet and ROMP. Qualitative comparison between 3DCrowdNet, ITL MeshNet, and PostMesh. Qualitative results from different views. To summarize, the bottlenecks of 3D human mesh estimation from in the wild crowded scenes are the domain gap and the global average pulling. 3DCrowdNet resolves them each in the feature extractor and a regressor. It produces much more robust 3D human meshes from in the wild crowded images. Thank you for listening. The code implementation of 3DCrowdNet is publicly available.